Good evening, everyone, and thank you for joining us today. I'm Shama, Manager People Solution at Kadel Labs, and it's my pleasure to welcome you to another exciting session in our Expert Insight series, the KL Tech Talk. At Kadel Labs, we are committed to sharing knowledge that drives innovation and transformation. Through this series, we bring insightful discussions from industry leaders to empower professionals like you with the tools and understanding needed to stay ahead in an ever evolving landscape. So, let me briefly introduce who we are. Kadel Labs is the first of its kind venture studio in India, a global technology incubator with a synergistic blend of IT services and SaaS products. Since 2017, we've grown organically to 180 plus employees, serve 200 plus customers worldwide, and with a global presence with operations across multiple regions. Our expertise spans diverse industries such as fintech, health tech, edtech, retail, insurtech, manufacturing, and telecom. We specialize in delivering innovative solutions in cloud engineering, data analytics, software development, and AI services. At Kadal Labs, we pride ourselves on being a people centric organization, encouraging creativity, free flowing communication, and continuous innovation to deliver impactful products and services to our clients. Today's session is part of our ongoing effort to address pressing challenges and explore transformative solutions. We are thrilled to introduce the topic Predictive Analytics for Mortgage Default Risk Management. Is transforming mortgage risk assessment, reducing defaults, and optimizing lending strategies. From AI driven risk modeling to predictive credit scoring, these innovations are making lending smarter and more secure. We are honored to have Mr. Saurabh Ray as our speaker today, a visionary AI engineer and industry leader. He has developed groundbreaking solutions in machine learning, blockchain, and NLP across sectors like healthcare, insurance, and public safety. So, beyond his expertise, he's a passionate speaker and a mentor, sharing his insights on data science and technological advancements through podcasts, webinars, and industry talks. Join us as Mr. Saurabh Ray shares insights on leveraging AI for better mortgage risk management. Drop your questions in the chat and we'll address at the end of the session. And thank you for joining us. Let's dive in and explore AI's impact on the future of mortgage lending. Over to you, Saurabh.
Thank you. About evening, but I'd say good afternoon, everyone. I'm Saurabh here, currently working as a lead data scientist with IBM products. Today, I'll be presenting a small session over mitigating mortgage risk, leveraging predictive analytics. Yeah. We'll explore how data science on a high level can help mitigate such problems. What are the root causes which leads to this situation? And as a general consensus, what should be and what should not be done. So, to get started, we talk about something called the ripple effect. Okay? Before we start, mortgage default. The term might sound heavy, the might sound usual, the term might sound familiar, it may sound unfamiliar. We have people across diverse backgrounds. So, what actually is a mortgage default is something which we need to understand first. If you have access to microphone, feel free to chime in here. I'll pause for a minute, or else you can use your chat window to give me your understanding. If I use just the term mortgage default, what do you mean by that? So, mortgage default is usually any type of default which a lender takes when borrowing an amount. This can be a secured investment or unsecured in nature. Any time we are not able to pay back our liabilities, we use the term default. So, why is this so critical? People defaulting payments is a common norm. So, why so much fuss about it? If we recall, go back about 15, 16 years ago, 2008 was here when US hit a financial crisis. And if we want to go to the depth of it, what was the reason? It was huge amount of financial default, which had caused this mortgage risk. If you see this graph, it's just not here for the purpose of adding a visual aspect of it. It is actually here to signify the same reason that the index went very high during this period. When there was an economic breakdown, there were jobs cutting. So maybe the industry we're talking about is finance and banking. But the after effect of it, every industry is linked to it. There will be stock markets which will get disrupted. There will be a price index which goes up. There could be the cost of living would go up. The money conversion ratios go down. So eventually, every common man is getting impacted. Governments get impacted just by one reason, that is rise in default standards. So how can you predict such situation is the key. Because if a situation we cannot see coming forward, you cannot be prepared. The recent pandemic, which we all have overcome right now, nobody really saw it coming. And that's where the nationwide lockdown happened. The industries were put a pause. There were massive amount of job cuts which have happened. There were situations where the financial status had to take a step back. It was in hold, and then a recovery was planned. But in this situation, just not finance, but any market, if a crisis is predicted beforehand, there is always a way where you can take a measure to control it. So the question here is, how would you predict it? The simple answer is data. You need lots of data. If you have the data, then there are ways you can leverage the data. But the key point here is, do we have sufficient data to solve this problem? If you need to predict a financial crisis, a mortgage default situation, what type of data do you think ideally institution would want to analyze so that they can analyze your profile? A small hint would be people applying for credit card applications, or people applying for a home loan or a personal loan. There is an approval ratio. There is a rate of interest which varies in few markets. So what do you think institution look into these data so that they can continuously evaluate and analyze if there is a risk or not? Can someone chime in? I'm not looking in the window. If somebody is writing a chat, Shama, please help me out there. But I want to hear from you people if you have any idea what would an institution look into as a data. Any daters?
Racist?
Okay, employment rate. Fine. Anything else from anyone?
No, I think we can take it forward.
Employment rate, yes, can be an index, but I would say it's not going to be a primary index whenever institution is going to evaluate your data. Okay? Because think of a situation if somebody is unemployed, does that mean that they cannot lend money? Maybe they need money just to start a business. So ideally, what institution would want to look in your history is if there is first any history where you have a credit profile. The primary matrix which will come to anyone's head is going to be your credit score. What is your credit score made up of? Your credit score is developed using your past lending history. There can be situations where threads around the lineage is also checked if there is any other history of a potential risk or a delay in a payment. It could also take into account how much asset you have. It can take into account how much debt to asset ratio or debt to earning ratio is there. So these are some useful metrics that institutions will evaluate before lending you a loan. Even after that, there can be a default. We're not saying that the moment you analyze these data points, we may take a default completely. But these are some initial grounding blocks which institution is going to take. But the question is, why at all are we discussing this here? Fine, there is going to be a financial institution who are going to look into this matrix. How is actually this data going to help me as a user understand the economics better? The simple answer to this is, if we want to bring functional aspect of a problem and solve it using a technology, we need to understand the fundamental process of the business. How does the module work? The functional aspect of it. And only then you can start making sense out of your data so that you can bring a technical aspect of it to it. Because if there is an historical data, let's say petabytes of data which you get of financial lenders, maybe these are masked, personal data not getting revealed, but all the financial documents are there with you. Still, there has to be a way how do you churn out that data? How do you call what is a feature for you? What is your target for you? So to understand these aspects, we need to understand what will help me solve my problem. Whenever we say that we are going to predict our future with data, we need to understand from the data what do we really need and what is noise. That reduction will only help me create a good balanced predictive model. So on that ground, we'll move forward, understanding the drivers of default. Mortgage defaults are influenced by certain categories. And whenever I want to bring a predictive model into the picture, these categories are going to be the features on which you will train a machine learning or a deep learning or an advanced predictive model. It could be a simple categorical model or it can be an ensemble of techniques. If you have really good amount of data, which that much volatility, then it can be even a depth of a neural network model. But irrespective of what your technology is, what is not changing is the drivers of your default, which is going to be your categories. So it is essential to understand what will be your feature, which will give you your final target. Because if you do not have the ability to develop the right feature selection, you will not end up creating a model which is going to give you the desired predictive outcome. So here in this slide, what you could see is there are certain external factors which might not be also visible in your data. So these are macroeconomic factors. These can be some GI indexes. These can be volatility indexes. Third-party sources collate those data maybe from a nation level or from a continent level, map it down to economic data, and then add it as an additional features. So this process of infusing features which are existing available with financial institution and with nationwide economic institutions is what we call as feature selection. And that helps you develop the key foundation of a model, which will help you predict a default. Any question, Antonio? Okay, I'll move forward. If you have, please feel free to write it down so that later on you do not miss out if you have any query and we can address this at the end. Okay, right. Now that we understood that what is my problem, what do we need to develop a solution, the whole agenda is how do you develop a good predictive model. Before we go to the depth of a predictive model, we need to first understand the context of a predictive model. Does it mean it is going to be a classification model only? Is it that it has to be a regression model or it has to be a forecasting model? There are so many terms which are overlapping. People use jargons, technological terms here and there. What you need to understand is these are mere terminologies. You don't need to get carried away if somebody is saying classification, it means naive Bayes theorem. This is a very common thing which I've seen with people generalizing words and trying to mix the technologies there. Predictive model in this case is simply going to be any model which is going to help you predict, in this case, a default. It can even be an Excel algorithm. It can be a macro. That can also be a predictive model. We do not need to reinvent the wheel and use complex terminologies to solve simple problems. Sometimes, basis on the depth of your data, it could be a complex model such as a neural network. Okay. So ideally, what do you need to do is whenever you have a problem statement which you're trying to solve, your key driver is you first evaluate your data, how complex your data is. Is it a simple data with, let's say, 5 or 6 features and then your final target? Or is it data where you are bringing in multiple data sources, appending them, stitching them together, creating a composite feature, and then developing your model? Basis on that, you will choose a final model and then create it for yourself. Some good approaches here would be a regression model. It can also be some ensemble techniques such as XGBoost, random forest. And in few situations, it could be a custom neural network layer where you maybe have a model with 10 to 15 layers. It's highly unlikely that you would need some pre-trained models, but given the kind of data sets which are coming into this, if needed, you would also have to take up those aspects. But the whole point is whenever you develop a model which is going to help you predict this future, you need to rely first on your data and then try to bring a technology. Not that I have decided that I will use XGBoost, whatever be my data, this is the best model. Because there are so many forums which are saying that XGBoost usually performs well in this data. No. The right way is look at your data, visualize your data, look at the charts, look at the graphs, look at the distribution, understand if you even need to transform that data, if you need to treat some anomaly, you need to verify some sources, and then take a call what would be the best possible model which can solve my problem. Because it could be a very simple solution, without using complex terms. What is the term which we use today? We use Gen AI. Maybe you don't at all need Gen AI to solve every problem. So don't try to run after a technology. Look for a solution for your problem. It could be a very simple model. So that is what you need to develop a predictive model. Now, this is where it gets interesting. What usually happens in a product life cycle, you have developed a product, got a very good model. But what was your end goal? Your end goal was always about understanding the problem, which is a default, and then trying to get a solution for it. If you have a mathematical model which is able to predict zeros being people who are not defaulters, one, let's say, people who are defaulting, how does it really help somebody mitigate the problem? How does the risk get reduced by that? Let's assume that their data is solved, the model is developed, everything is done. What next? The hints are there in front of you. It's on a high level, but I'd want to hear after that. How do you derive the success out of it? Okay, correct. So you have to derive your outcome from that. The moment I get somebody as a risky profile, what next? Measures could be a direct no, where we have tagged them as defaulters using the risk assessment we have done, or it could be some proactive measures where you understand what could be a factor leading to this risk. How do you do it? From a technical term, you would look at different weights of your features. You will look at your features, let's say age, maybe the income to spend ratio. You look at total debt which an individual has. You look at the stability index. And after that, there are going to be 7, 8, 10 features which is going to lead you to your final decision that yes, this is a risky profile. Every factor will have its own weightage. So you focus on the high factors, which X is different from Y. There can be two individuals, both are risky, but the reason of your risk may vary. So in few cases, it is highly possible that it's a very red profile, it's a risky profile, and you don't lend them. But in few cases, you could take proactive measures where maybe the rate of interest gets increased, or there has to be a security because it's a business. At the end of the day, if you don't lend, you don't earn out of it. So there has to be a transaction. There could be risk mitigation measures. There could also be a future model. So once you have got a classification model, which classifies an individual as risky or non-risky, you can then transform it to a forecast model where you take these metrics and then forecast that if, for example, lended person X an amount for a tenure of 10 years, there is likelihood that this person is going to default. But possibly this person is going to default on 3 occasions. This person might not default on the complete amount. Or it is possible that this person may repay it back in instead of 10 years, then it will be in 12 years. So if I collate all the list of defaulters, how much of my capital is actually stuck? What is the period in which this recovery can happen? And what could be an appropriate rate of interest which could be applied in the beginning so that I forecast this risk and that amount which is now as a buffer for me, I can bring it in the early years. So these are certain measures which institutions will take before they take a call whether they are going to give you a mortgage which is being allowed, denied, or at a higher rate of interest. And in few occasions, there has to be a guarantee where they feel that it's a very dicey situation, but you do not have solid grounds to reject it. So there are multiple ways you could transform it. Another key insight which institution might take is that they would want to transfer your existing debt to their institution so they can recover it and that could be additional earning. These are certain transformations businesses will take so that the capital is safe enough. Okay. Finally, now that these possible options are at the table, how do you derive if your solution is success or not? The derivative of it is always dependent primarily data quality. We are relying on historical data. If your data itself is noisy, if your data itself has got wrong values, there is no model in the planet which can give you a right prediction because it is relying on that data source. So your data quality is very important. Your data selection is then very important because the raw data has to be transformed to trainable data. Your feature engineering is how do you select your attributes out of these data points is important. Then how well have you interpreted your model? The model is giving you a result in the form of yes and no's. but you will have to drive an insight out of it that you're going to present to the stakeholders. This is what we can do with these profiles so that we can still generate revenue, generate business. And eventually, since this was historical data, a data set which was 20 years ago or 30 years ago curated might not hold true in today's date. So you'll have to continuously evaluate your data, monitor it, and retrain your models so that you're future ready. This is the key pillar aspect continuous monitoring, which major players have missed out and have led to financial defaults. If you do not monitor a data set which was in today's growing era specifically, a 30 years old data is not going to help us. So, and continuous improvement is essential. These are the pillars which eventually help you go ahead and derive your success story in predictive analytics. Okay. So to summarize, how do we transform mortgage risk assessment with data science? A, predictive analytics will define how mortgage risk can be assessed, mitigated, or resolved. With the help of data science techniques, we can achieve plethora of informations, insights about what could be a risk factor for an individual. How do you transform a risk into a profitable situation? And then how do you take actionable insights so that a business revenue can generate it? Anyone has any queries? This is an open forum now. Please feel free to ask anything.
Yes, we can unmute ourselves and ask the question directly to the speaker if we have any. And we have one in the Q&A session section as well.
Okay.
So the
Okay.
question goes this way. What are some real world success stories where predictive analytics significantly reduce the mortgage default risk?
Unfortunately, we are not allowed to speak on real world client solutions because we cannot take the name of institution with which we have worked. But a key example, which I've already highlighted, is the 2008 scenario. That was an eye opener to institutions. Until 2015, 2016, data science solutions adaptability was comparatively low. Finance is a very critical topic. Usually, financial institutions are not pretty open so that their data can be exposed to models, specifically if they are open source. Initially, we were housing data open source. Today, there is Azure, there is AWS, there are multiple platforms on which your data is pretty much secure, and there is a shift happening around institutions. So I will restrict myself from listing out financial institutions' names because the contract does not allow me to do it. But yes, there are some leading players, global players specifically, who have adapted into predictive analytics solutions. And aspects where it is coming in is usually the HNI profile, where you would want to evaluate such profile extensively so that the risk monitoring ratio is well managed. There can be a follow-up question that still we hear stories that there are financial debts organization and there are unforeseen amount, huge sum of amount which goes away. Trust me, the system is not that transparent. There are ways in which transaction can happen beyond the ledger book. So it's an infusion of AI plus blockchain, and there are transactions which can happen outside of that. That also leads to a risk. But in today's date, most of the Western banks have got AI solutions incorporated into it.
Great. I think they have got their answers. And we have one
Okay.
more question from the students who have joined us in
Mhm.
this session. So, what
Mhm.
programming languages and tools are commonly used for the mortgage risk analysis?
Okay. There are two programming languages widely used in the data science industry. One is Python, next is R. Okay. R in today's date is losing its shine, which it had in earlier days. Still, for statistical analytics, is a very good model. But with the open age era where cloud is really taking a boom and the cross compatibility of Python would be your primary language to drive with it. When we talk about tools, see, it's data science is no more complex how it used to be 6 years ago. There could be utilities such as AutoML, which is already present within Azure, and people who are clicking it are able to do it. But the whole idea, it's always better if you can do an hands-on activity. Take your Python editor, it could be VS Code, it could be Notepad++, it could be anything. It can be even be Jupyter Lab. You bring in your data and then leverage libraries such as scikit-learn. You use TensorFlow, use Keras. You go ahead and try out statistical models such as ARIMA. So these are some good forecasting models, predictive models, which can be built out of the box. That helps you to understand your data well. When you are working in an interactive environment, if you are a beginner, it's highly advisable don't run after tools because tools will you are going to click some tools and you're going to get a result. But the whole process of understanding what is an outlier, how do we call a data distribution to be noisy, you would not be evaluating it. You would be rather leveraging a tool to get your final solution. So for beginners, I'd strongly recommend get into hands-on coding, use these open source libraries. You have plenty of material available in the web. There are a good amount of trainings that could help you draw the solution. But yes, what you definitely need is a hands-on data set. If you don't have control over data, you cannot do it. So yes, there are sample data which are available in the web. You can use that, and your primary go-to tool is going to be Python. Rather than me, I'd say.
I think you have answered the next question as well that we have. So the
Okay,
question goes, what are the skills should students develop to pursue a career
mm.
in predictive analytics and mortgage risk
So
management?
it's pretty much the
Yeah.
same answer.
I think we have answered two questions. Do we
Okay.
have any more questions? I think we can unmute ourselves and ask Saurabh directly.
Okay. It seems
All
we have
right,
no more
yeah, seems
takers.
like we have touched upon all the topics. Thank you,
Yeah.
Saurabh. Thank you so much for your time. We
My
had a
pleasure. No
great
worries.
evening with your knowledge and insights on predictive models and analytics. Thank you, everyone, for your time. I hope you have enjoyed today's session. See you all in the next session. Bye bye.
Thank you. Bye bye.